Okay, so we're going to go over 3.4, 3.5 practice problems. Let's go through our objectives first. The first one is that we want to be able to write a linear equation in intercept form from a recursive rule, a graph, or a table. We also want to be able to identify the y-intercept and the rate of change from an equation in intercept form. We also want to be able to find the rate of change from an input-output table. And we're going to go through each of those in our 4 practice problems. Let's go over intercept form again really quick. So intercept form looks like this: y equals a plus bx, where a is one of our variables, or y is one of our variables, a is a constant number, b is a constant number, and x is our other variable. A will represent the y-intercept, and b represents the slope. So remember what the y-intercept is. So if we have our coordinate plane, we have our y-axis and our x-axis, and we have a line. This point right here, where the line crosses the y-axis, that is our y-intercept. So the ordered pair for the y-intercept is going to be 0, a. 0 is our x-coordinate because we're not going left or right of the y-axis at all. We remain on the y-axis, so we stay at 0 for x. And then y, the y-coordinate, is going to be this value, that a number. Okay, and then our slope. Slope tells us the steepness and the direction of our line. So the direction of the line, I'm talking about whether the slope is positive or negative. So a positive slope is going to look like this. When we're going left to right, the line is going upward. It's like we're climbing up a hill. And then a negative slope is going to go from left to right, it goes downward, like we're skiing down. So positive, negative slope. And then the steepness of the line is determined by that number b, And that b is equal to the change in y divided by the change in x. We also call that the rise over run. So let's look at that on the graph. So if I have 2 different points on the line, and I'm trying to find this slope of this part right there in between. What I'm going to look at is the rise, so the change in y, the amount that we change vertically, and we compare that to, we divide it by that change in x, the run. So rise and run. Okay. All right, let's look at, we'll start with, one more thing I want to talk about is, so if there is not a value for a, if there's no value here, if we just have something that looks like this, y equals bx, then our y-intercept is 0. Y-intercept is 0. So that means that the line would cross at the origin. And then if there's not a value for b, if we have something that's like 1 plus x, and there's nothing there in front of the x, the slope is equal to 1. Okay, let's look at number 1. We'll go through each of these. So first one I did for you, we're looking for the slope and the y-intercept from the equations. This is the second objective, identifying the y-intercept and rate of change from an equation in intercept form. So this first one, we have y equals 50 plus 2.5x. Again, this constant number is our y-intercept, and the coefficient of x is our slope. So the coefficient of x is 2.5, it's positive 2.5, and then our y-intercept is 50. Now for b, y equals 3 plus x. So our slope, as you remember, if there's not a value for b, if there's not a coefficient of x, then the slope is just 1. And then our y-intercept is this constant number, which is 3. For letter C, we have y equals -8 minus 5x. Our slope is the coefficient of x, and it's not just the 5. We include that negative as well, that subtraction sign. So the slope will be -5. And then our y-intercept, again, is just that constant number, which is -8. Now the last one, so this one's a little different. We don't have an x value. Don't have an x value. So what you can kind of think about it like, we kind of have an invisible 0x there. Because 0 times anything is always equal to 0, right? So we can add that on. And so that's going to still be our slope. That slope is going to be 0. And then the y-intercept remains the same as 1/4. Let's take another look at that. We'll look at it as a graph. So on my coordinate plane, I have my y-axis, my x-axis. My y-intercept is at 1/4. I'm going to make this 1. So this would be 1/2, and here would be 1/4. So that's my y-intercept. When we have a slope of 0, that means that it's a horizontal line, which means it's just straight across. Okay. And so it's, again, the equation is y equals 1/4. So that means anywhere along this line, y equals the y-coordinate is going to be 1/4, no matter where we are. The x value will change. We can be at 0, we can be at 1, we can be at -1, but the y value always remains as 1/4. So big takeaway from that is if we don't have an x in our equation, that means the slope is 0, and it means that it's a horizontal line. Let's go over to the next page. Get number 2. So we're looking at the graphs of Percy and Quincy. Let's see, can't make that any greater. So Percy is up here in the first graph, and Quincy is down here. Our first task is to write a recursive rule for the sequence of each rabbit's jumps. So think about the two parts of a recursive rule, where we have a starting point and we have a rule to get from term to term. So the starting point for Percy is right here, which is going to be at 9. So start at 9. And then, how do we get from term to term? How long is each hop? So when we go here to here, we can go 1, 2, 3. So we're adding 3. And then again, 1, 2, 3, add 3. So to go from here to here, 9 to 12, we add 3. From 12 to 15, we add 3. And that's what we'll do the whole way. So start at 9, and then for each hop, add 3. Now Quincy will do the same thing. Think about starting point and then rule to get from term to term. So Quincy starts right here at 49. So start at 49. And then he's moving the opposite direction. So for every hop, this time we are going to subtract. So for each hop, subtract. And how much are we subtracting? We go back 1, 2, 3. 1, 2, 3. 1, 2, 3. So subtract 3. Okay, and then the second part is just taking these recursive rules and using them to write an equation in intercept form, where y tells us the location of the rabbit at any point in time, and then x represents the number of hops that that rabbit takes. So let's look at Percy first. And first, let's remind ourselves what intercept form looks like. Y equals a plus bx. Y equals a plus bx. So b again is our slope. It's also our, which is the same thing as the rate of change, the rate at which the variables are changing. And then a is our y-intercept. So also, you might remember from the investigation we did about the cars, the y-intercept is our starting point. It's the 0th point, 0th hop, 0th time. It's going to be that starting value. So when I write my equation, I keep that in mind and I think, okay, so I want to have something that looks like this. That's y equals, and then the starting point, which would be 9. And then for each hop, add 3. That means 3 for the first hop, and then add 6 if there's 2 hops, add 9 if there's 3 hops, add 12 if there's 4 hops. What am I doing there? I'm multiplying. I'm multiplying 3 by the number of hops the rabbit takes. So I get 9 plus 3x. Now for Quincy, again, I have y equals, and his starting point is 49. He's going back the opposite way. The numbers are getting smaller and smaller. So I know I need to subtract, but it's still that same 3x, minus 3x. And those are my equations. Just real quick, let's point out the y-intercept and the slope of those two equations. So y-intercept here for Percy is going to be 9. And the slope would be positive 3. And then for Quincy, our y-intercept would be 49, and our slope here would be negative 3. Let's go on to number 3, where we are going to complete an input-output table. So what we're going to do for this is we take our x values here, and I kind of picked those randomly. I did have a little logic in mind, I guess, where I wanted to choose something that is negative, I wanted to choose 0, and I wanted to choose at least one positive number. And that just helps me when I want to graph, and we'll graph this when we're done filling out the table. I want to be able to kind of have a clear idea of what this graph looks like. Negative with a negative x value and with a positive x value. Okay, so I can get like kind of more of a full picture of the graph. So first one I did for you, I picked -1 and I plugged that in for x. So I got y equals 3 plus -1. 3 plus -1 is the same thing as 3 minus 1, which gives me 2. Now, for the next one, I plug in 0. So I get y equals 3 plus 0. 3 plus 0 is just 3. Now the next one, I get y equals 3 plus 1. Plug 1 in for x. That gives me 4. And then the last one, I plug in 5 for x. So I get y equals 3 plus 5, which gives me 8. Now each of these rows tells me a different ordered pair. It tells me a point on the line. So I'm gonna plot these different points so that we can see the graph of this line. So I start with -1, 2. which is right there. And then 0, 3. So I don't go left or right at all. I stay at 0 and go to 3. That is my y-intercept. Then I get 1, 4, right there. And then I go to 5, 8. So 1, 2, 3, 4, 5, and then 1, 2, 3, 4, 5, 6, 7, 8. And then all I need to do then is connect the dots. So something I want to point out is what this line tells us is the collection of points that satisfy this equation. The collection of points along this line, any point on this line, is going to represent a solution to this equation. Any point on this line tells us an x and a y value. So I just plotted a point right there that is 1, 2, 3, 4, and 1, 2, 3, 4, 5, 6, 7. So that's 4, 7. If I plug in that x value and that y value into my equation, what I'm going to get is 7 equals 3 plus 4, which is true. 3 plus 4 does equal 7. So we'll keep talking about this too, but every single point on this line is going to be a solution to this equation. Right, let's get on to our last one, number 4. So we have, we want to use these input-output tables to find the rate of change and find the y-intercept. Then using the y-intercept and the rate of change, we want to write linear equations. So this first one, let's talk about the formula for rate of change. So the formula for rate of change is this: the change in y divided by the change in x. So that's going to equal one y value minus another divided by x value minus another. And what these little numbers down here tell us, it's just like a naming system where it tells us like this x1 corresponds to this y1. This x2 corresponds to the y2. x3 would correspond to y3. So those numbers just kind of match up the x and the y value. They'll show up on our input-output table right across from each other. So in this example, I chose 5 as y2 and 4.5 as y1. And then so the corresponding x value here would be 0, so that's going to be my x2. And then my corresponding x value for this one would be x1. And then all I need to do is plug those in to this equation. So we get 5 minus 4.5 divided by 0 minus -1, which gives me 0.5 over 1, which just equals 1/2. And then remember, y-intercept is where the graph crosses the y-axis. It's what y equals when x is 0. So when we're traveling along this x-axis, when we get here to 0, where is that graph? Where is that line? So in this example, when x is 0, y is equal to 5. So that's my y-intercept. I found my y-intercept, I found my slope. Now all I need to do is plug that into my equation, my intercept form. A is my y-intercept, B is my slope. So I plug that in, so I plug 5 in for A, so I get y equals 5 plus 1/2 x. That's my answer. Let's do the same thing down here. So I got y2, y1, and x2, x1. I plug that in, so b is going to equal change in y over change in x, y2 minus y1 divided by x2 minus x1, which equals negative 2.5 minus negative 6 divided by 1 minus 0. So negative 2 minus negative 6. When I subtract a negative number, they both turn positive. So I have 6, negative 2.5 plus 6. Another way to think about it is 6 minus 2.5, which gives me 3.5. And then 1 minus 0 is just 1. So my answer is 3.5. That's my slope. Then my y-intercept, I just go and I look. When x is 0, y is negative 6. So I use this as my y-intercept, this is my slope, and I get y equals negative 6 plus 3.5x. Now for this one, I'll choose y2, y1, x2, x1. It doesn't matter which ones you choose, you just want to make sure that the x and y correspond to each other. I couldn't choose like, you know, y2, y1, and then x2, x1, because this and this need to, the y1 and the x1 need to correspond with each other. They need to be right across from each other. So this is x1, x2. Okay, so I write out my equation. B equals change in y over change in x, which equals y2 minus y1 over x2 minus x1, 25 minus 1 over 3 minus 0 gives me 24 over 3, which equals 8. And then my y-intercept is the y value when x equals 0, so that's 1. So my equation will be y equals 1 plus 8x. Here's my solution.